Hey guys, this is Alan with Bothell STEM Coach, and today we're going to be starting the AP Calculus 2007 free response questions. So let's take a look at some of these problems here. All right, let's see. So this is the calculator section, so I have my calculator pulled up here. Let R be the region in the first and second quadrants bounded above by this graph and below. So this wording. Okay, so this kind of looks something like this, I think, ish. I don't know, roughly what that looks like. And then y equals 2 maybe here. And then, actually it's shifted over a little. Well, it's okay. It's fine. What does it do? Does it ever go? Actually, it, probably goes like this. Yeah. Probably has like a little cap here. So we're talking about this region right here. So find the area of R. Okay. The area would be the integral. Like if I think about it as like making like little rectangles here. Like I take my little slice of rectangle. Okay. What is the width of the rectangle is dx. The height of the rectangle is this function, this y value minus this y value. So it would be 20 over 1 plus x squared minus 2 dx. Now I got to integrate from this where the intersection points are. So I actually have to know where these intersection points are, these x values. So I want to know when this intersects that. That's when y equals 2 equals 20 over 1 plus x squared. That's 2 times 1 plus x squared equals 20. 1 plus x squared equals 10, dividing by 2. X squared equals 9. So x equals plus or minus 3. So I'm going to integrate from negative 3 to positive 3 here. And let's see what the calculator does here. Integral of 20 divided by 1 plus x squared minus 2 comma over x from negative 3 to positive 3. 37.96. Okay, so that's part A. Part B, find the volume of the solid generated when R is rotated about the x-axis. So now I'm going to take this rectangle, and instead of computing the area of the rectangle, it's going to sweep out a disk, right? If I think about this rectangle, it's going to sweep out a disk like this. Okay. Now the length of this distance here is the same as this one here, but to find this, I want to find the volume of this disk because it creates a three-dimensional. There's like a little bit of a thickness here I didn't draw. If I draw a little bit of perspective, you can kind of see that it has some thickness here. Now the dimensions of this disk are, well, the thickness is dx. To find the volume, I take this donut area times the thickness. This donut area is the area of the bigger circle minus the area of the smaller circle. The radius of the bigger circle is the distance from here to here, which is the y value. So that distance is 20 over 1 plus x squared. And this little distance here is just 2, the distance from here to here. So the volume then is 20 over 1 plus x squared. This is pi r squared. That's the area of the big circle minus the area of the little circle, pi little r squared. All of that times dx is the volume of this disk. Then I want to sum up from negative 3 to 3 over all the disks here. Okay, so I'm going to enter that in math 9. So I'm going to do pi. Where's pi? Pi is here times 20 divided by parentheses 1 plus x squared. All of that squared minus pi times 2 squared is just 4. Okay, I'm going to integrate over x, and again I'm going to go from negative 3 to positive 3, because I want all the disks from x equals negative 3 to positive 3. That becomes 1871.19. Yeah. C. The region R is the base of a solid. For this solid, the cross-sectionals perpendicular to the x-axis are semicircles. So now this rectangle forms a semicircle. So if I kind of draw this rectangle here, this is the same rectangle, but it forms a semicircle kind of shape like this. Okay, and I want the volume of this circle. Now the dimensions are, the thickness of this is still dx. This whole length we decided was 20 over 1 plus x squared minus 2, right? That's what this is, this value minus this value. That's sort of the length of this. So the radius r is equal to 1/2 of this. 1/2 of 20 over 1 plus x squared minus 2. And multiplying that out, I just get 10 over 1 plus x squared minus 1, distributing the 1/2. So that's what the radius is. And the area would be 1/2 pi r squared, because pi r squared is the area of a whole circle. So the area of just half of a circle would be half of that. So it'd be 1/2 pi times 10 over 1 plus x squared minus 1 squared. That's the area. Okay. So to get the volume, I just take that area and multiply it by dx. So we say the little volume of this slice, this little circle, is this. And then I want to add up all of the volume, sum up the volumes of all the disks between x equals negative 3 and 3. 1/2 pi 10 over 1 plus x squared minus 1 squared dx. Okay. So function integral 1/2 pi 10 divided by 1 plus x squared minus 1, all of that squared, integrating over x from negative 3 to 3. I get 174.268. Okay. Let's check if that looks right. 37.96, I didn't do 2, 1871.190, and 174.268. Okay, so hope you guys found that helpful. I'll see you guys in the next video. Thanks for watching the video, guys. Please leave a comment, like, or subscribe below to catch up more of the content, and see any links below. I offer free homework help on Twitch and Discord. See you guys in the next video.